Welcome back, scholars. Experimental Design, Day number 2. Mr. Sarles here again. When we left off yesterday, we were talking about sampling methods. Determine which sampling method was used in each of the following examples. So pause your video, make a choice, and then come back when you're done. All right, let's see how you did. Here are the answers I came up with. Go ahead and pause the video, take a look at these answers, and when you're done, hit play again. Quick review from yesterday. Bias, where the method you choose systematically favors a certain outcome. This gentleman down here asking people outside of target field, what is your favorite sports team? I think you are going to overestimate the percent of people that say baseball, because you're asking people right outside of a baseball stadium. All right, new stuff for today. Types of sampling bias. We're going to talk about undercoverage, non-response, response errors, and how wording of questions can bias the results. First type, undercoverage bias. It's when some members of the population that you are studying are inadequately represented in the sample that you have taken. And the bias occurs if the opinions who you didn't sample differ from those who you did take a sample of. An example on the next slide will make it more clear. Here's a hypothetical example that I made up. You ask a sample of 200 people that are entering a Costco store next to your house. Are you in favor of Governor Walz's extension of our stay-at-home order? Let's say you find that 47% of those sampled are in favor of the extension. So you make a point estimate that 47% of all Minnesotans are in favor of the stay-at-home order extension. 3 questions. Number 1, what sampling method did you use? How could this method result in undercoverage bias? Explain your rationale as to what direction you think the bias will be. Pause the video, try to answer those questions. I'll reveal the answers in just a second. Type of method used? Convenience. You ask people close to your house, all going into the same store. Also, voluntary response, because when you ask somebody, they could refuse to answer. So how does this result in undercoverage bias? Another way of asking that is, whose opinions are not being counted in the sample we took? Well, I would argue you would not get representation for anyone who doesn't shop at Costco, and perhaps their opinions are different than those who do. And what about people that shop at Costco's but are in a different part of Minnesota? And here's the big one. You wouldn't get opinions of those people who are choosing to stay at home and not shop for groceries at all. Now, direction of the bias. Look at this 47%. Do you think it actually overestimates or underestimates the true percent of all Minnesotans who are in favor of the stay-at-home extension? Looking at the people that are not being represented in our sample, especially this third group, those that are choosing to stay at home, their opinions were not reflected in the sample. Because of that, I think this 47% actually underrepresents the true population of Minnesotans that would be in favor of the extension. Here's how I wrote that out in a sentence. Read that, move on when you're ready. Type number 2, non-response bias. That is when the individuals chosen for the sample are not willing or unable to participate in the sample. Bias occurs when the opinions of those who did respond do not match the opinions of those who did not respond. And the visuals here show people either unwilling or unable to respond. Okay, let's look at an example. Okay, another hypothetical example. State of Minnesota creates a survey asking residents, do you report all of your earned income when completing your yearly taxes? 1,000 people responded to the survey. 97% of those people that responded said, we report all of our earned income. Try answering the 3 questions below. Pause. When you're ready, come on back. Okay, it doesn't tell me how the surveys were administered. Were they mailed out to the individuals? Was it an online survey that people could choose to complete? But it does say of the 1,000 completed. That tells me voluntary response. And how could we end up with some non-response bias then? In other words, who would not respond? Well, my thought is those individuals who do not report all of their earned income would be reluctant to complete the survey, especially if the survey states that a government agency is collecting this information. Direction of the bias. Do you think this 97% that we got from our sample overestimates or underestimates the percent of all Minnesotans that report their income? Here's my thought. I would expect the methodology would overestimate the proportion of Minnesotans who claim all of their income. The reason? Because of the non-response of those who don't claim their income. Okay, third type of bias. It's an error introduced into the survey results due to respondents providing untrue or incorrect information. Third type of bias, response error. This is where there's a mistake in the error, either because the respondent was being untrue or answered the information asked incorrectly. So the bias from this one results from the sample data not correctly representing what you are trying to measure. Here's an extreme example. Eden Prairie High School wants to know what percent of its students are using drugs and alcohol. To get this answer, the counselors call students into their office and do the following. Hey, tell me, have you used drugs or alcohol in the last 3 months? The student replies, no. So how would bias occur in this methodology? I think the methodology you're using this time makes it hard for a kid to be truthful. You have somebody sitting there right in front of you asking you if you are doing something that is illegal in the school. In the bias, I think you are going to underestimate the true percent of kids using drugs and alcohol because of the method being used. Okay, I've redisplayed the cover for today's presentation. Notice how it deals with response error. Pause, read through it, and come back. And I hope this stats part of the course, you're starting to love messing with data. Last type of bias is based on how you word a question. So certain outcomes can be systematically favored based on the way that you word the question. Here's an example. State of Minnesota has extra money, wondering what to do with it. Should we give it back as a tax refund, or should we use it for programs for the state? A survey is created that has both of these questions. Should the money be used for a tax cut, or should it be used to fund new government programs? Second wording of it, should the money be used for a tax cut, or should it be spent on education, environment, healthcare, crime fighting, and military defense? So the question is, predict the percent of the people that responded that want money to go towards government programs. Now you should get the percents being exactly the same because it's really asking the same question just in 2 different ways. Let me show half of the results. For the first question, 40% of the people responding voted for new government programs. What do you think the percent will be for the second wording of the question? Pause, come back. Well, notice in the second statement of the question, it actually says what the new government programs are. and it's all good things, education, environment, and so on. So a higher percent of the people actually said, yes, I want the money to go towards the government programs in that question, even though these should have been the same. So the point taken, the wording of the question can drastically influence the results that you get. Okay, this slide, sampling methods on the left, bias underneath the shade. Voluntary response, convenience, systematic, results are often biased. Cluster stratification removes some of the bias because it has some randomization in it. Simple random sample, in this class, will be the gold standard. It's going to eliminate or minimize the amount of bias. And some of you, after taking the stats part of this course, may decide to take AP stats next year. If you do that, you'll hear us talk about cases where stratification actually gives you a better prediction than simple random sample, but we'll leave that discussion for the AP course for now. So, how do you get a simple random sample? To demonstrate taking an SRS, I would do the following. I would randomly select 5 students from the 26 kids in my first hour class. Winners get a bagel break coupon. Coupon they can use during work time to go take a 10-minute break in the commons to grab a bagel. To do this, I would have the kids figure out how they could use these random digits down here to select 5 kids out of the class. Okay, here's an example of a procedure we've come up with in the past. First of all, alphabetize the kids, number them off. So, 01 to 26, Yusuf 01, Mohammed 26. Ignore numbers 27 through 99. Also ignore 00 if it occurs. Skip repeats. Why? We don't want one kid to win more than one of the coupons. Next, start at line 28, picking 2-digit numbers. Continue until you have 5 unique numbers. The 5 students corresponding to the numbers selected win the bagel break coupons. All right, let's actually show what it looks like. Okay, let's show what this looks like. First 2 digits, 36. Nope. 80. Nope. 77. Notice I took the 2 sevens combined. 1, 4, 14. There we go, first winner. 2, 0, 20. Second winner. 35, nope. 80, nope. 44, nope. Pause the video, find the next 3 winners. I took the 5 winning numbers and then highlight the names that went with those 5 winning numbers. Wish I was back in class, guys, where I could give you those coupons in person. In the formal definition of SRS, this group of 5 students had the same probability of being chosen as any other group of 5 kids in the class. Okay, let's do the same thing on your calculator. If you haven't done so yet, through self-service, you can actually download an online emulator like the one you see on my screen right now. Okay, let's randomly generate 5 kids from my first hour class using a calculator. I'm going to go to the math button, one button below the green one. Now I'm going to scroll over to the probability column. I'm going to go down to random integer, hit enter. It says lower. I want to go from 1 to 26. I'm going to generate one number at a time, and paste will put it back on my main screen. Now I'm going to hit enter, and it's going to randomly generate numbers from 1 to 26. And notice there I would have had to skip the repeat. And I keep going until I get 5 unique numbers. I could have done it that way also. All right, thank you guys. That concludes day 2 of experimental design.